I want to offer up some help with proofs concerning congruence of triangles. I know they can be pretty tough, so I want to focus in on what is happening and ways to really think about and process these triangles. So with any proof, we always start with our given statements. We see we've got two parts that are given, and I also like to mark everything possible on the picture to make sure I'm visually seeing what's happening. So let's start with the first given part about angle YLF and angle FRY. YLF would be this angle here, and FRY is this angle here. It also says that RFY, marked with two congruence markers, is congruent with LFY. Maybe I mark those in a different color. So that's two pieces of information so far. I have two sets of congruent angles. So if I were to take some notes, that gives me two options. To prove that the two triangles are congruent, which just in case, we're talking about these here. This triangle, and then this triangle. Just to clarify what it is we're trying to prove. We can make a list. We could say that we could try angle, side, angle, or angle, angle, side. They're the only two choices that have two angles. One of the things that's really important here is use what's already in the picture. Notice each of these triangles share a piece. They share one of their sides right here. That side, as marked down in this fill in the blank proof, shows that the side FY is incongruent with itself, the side FY. We call that the reflexive property, and it's one of our best friends when it comes to proving congruent triangles. Now, with all this information, something I want you to think about is which one is this now? Angle side angle or angle angle side? I like to look at it in kind of a clockwise fashion. If I look at it this way around the triangle, I see an angle, and then a side. Angle, angle, side. So by angle, angle, side, these two triangles are congruent. So that's a lot to take in at first. But by looking at these fill in the blank proofs, we can try to start to understand and see if there's a pattern. There's only so many of these types of proofs you're going to see, so if we can establish some sort of pattern, that's really going to help. At any point, you can pause this so that you can also take some notes with it. I do suggest, at least from this point forward, you write down everything. Copy down the problem. Write your columns out, and then follow along as you're filling it in until you feel comfortable trying it on your own. All right, let's take a look at number 7. Got quite a few pieces here, and it looks daunting. I'll tell you what, that confuses my brain. Let's see what's happening. It says LT right here is congruent with TR. We have that ILT, this angle here, is congruent with ETR. And kind of an odd piece is that IT is parallel with ER. Those are supposed to be little triangles to show parallel. Well, there's a little bit of a trick to that, and I want to talk to you about what that is. Up to this point, we should have seen what happens when we have two parallel lines that are cut by a transversal. It tells us something important about these two angles here and here. Well, we would call those corresponding angles. And corresponding angles are congruent. So just some notes to jot down, because this actually starts to tell us we have congruence. Let's take a look. The first statement, side LT is congruent to side TR. Well, that was given. Step 2 is also our given. And then step 3. What we found was here in step 4, angle LTI, we highlight here, and angle ERT. Using our older skills, these are corresponding angles. And depending on how your teacher wants you to write it, there's many ways you could fill this in. Could be a theorem, anything, but I'm just going to put corresponding angles. Now look at our picture. We can start to figure out what pieces we have. This could be one of two pieces. I see we have two angles and a side, so is it angle, side, angle, or angle, angle, side? Again, I suggest looking at this using a clockwise fashion. If we look at our picture in clockwise, I start to see, oh, well, this angle, side, angle, it's the order in which it appears. So all we have is angle, side, angle. So some tricks to think about. In some cases, you're going to have to use your skills with parallel lines and the angles they create when they're cut by a transversal. And you're just going to have to use some of the pieces given. And as we saw in the previous proof, what do they share? Let's keep looking. All right, that's it for this page. Next page. I'm going to give you a fair warning. This is something you are going to see a lot. This picture is one I would say will even show up on a test. Let me change the zoom so I can see all of this at one time. Here we go. So let's start by filling in what we have. We have a given of 3 pieces, and they wrote it in 2 lines. Let us mark and see if this tells us anything. First off, this point C is a midpoint for BD. That means BC is congruent to CD, and that's by definition. We can say that's just definition of midpoint. Now, another important piece is the vertical angle theorem. If we look closely, line 4 says angle BCA is congruent to angle ECD. That's this angle and this angle. When we have angles that are kind of on the flip side of each other like that, they're called vertical angles. And according to the vertical angle theorem, they are congruent. It's also one of our handy tricks we can use a lot in order to solve these. Let's keep checking this out. So a piece I didn't mark is these perpendicular pieces. Keep in mind that a perpendicular, well, two lines that are perpendicular create a right angle. So we have two right angles. That is the definition of perpendicular. And let's see what we might be able to piece together. One of the things, I'll be honest, I am not 100% sure right now how to label is this part about ABC being congruent to EDC. There's a couple pieces that could happen here. One of the ways we could look at this is that AB, as part of this piece with the perpendicular, is if BD is perpendicular to both of those, they're actually parallel. These would be two parallel lines, here and here, cut by a transversal. And let's look. In between the two lines, we have these two angles. That means they are on the interior of our lines, making this alternate interior angle theorem. Now, we have all our pieces. Let's see if we can't figure out. Again, we have two angles and a side. So is it angle, side, angle, or angle, angle, side? By looking clockwise around the picture, I see an angle, side, angle. Therefore, triangle ABC is congruent to triangle EDC by angle, side, angle. So, important pieces are, of all of our main tricks, we've talked about, what about parallel lines? We have talked about what happens when they share a side, because that's going to be an important piece. And another piece that's going to be important is the midpoint and the vertical angle theorem. Those are going to be two cheats that when we see it in the picture, we want to automatically jump to it because it's going to help us piece this together. Pause this if you need to. Go back and watch the pieces again to see if you're starting to get an understanding. Let's look at number 9. Number 9 is another big kind of classic picture. It's very much similar to the one above. This definitely might pop up on a quiz or a test, so I want you to make sure you study this one. Let's begin by marking what we already have. BA is congruent to ED, and C is the midpoint, so BC and EC are congruent, and the other piece is it's also the midpoint for AD. Therefore, these are congruent. We can fill that in with some information. We have our given and our given. BC is congruent to EC by definition of midpoint. I could be wrong as I say that. This could be midpoint theorem. I would have to double check, but a midpoint cuts two lines directly in the middle. This is going to be the same line. I don't feel like writing it. And that actually solves this one very quick. We have a triangle that has three sets of congruent sides. Therefore, side, side, side is the reason why these are congruent. There are other ways that you will see this picture used. I have seen this picture where we would have those two outside lines as parallel, and we would have to use alternate interior angles. We would have to use midpoint and use the vertical angle theorem to start to piece this together. So there's more than one way you're going to see this picture. Just kind of a warning so that you don't jump to conclusions. All right, let's see what else we have. Another classic example. We have a parallelogram that's got a diagonal cutting it into two triangles. We are trying to prove that ABC is congruent to CDA. Well, we have a few pieces. BC and DA. AC bisects an angle. It bisects BCD. Therefore, this angle is congruent with this angle. And we've got a really awesome piece here. Is we have this reflexive property pop up right here. This line is in fact congruent with itself. So if I start filling in some pieces, we have given, we have given. This part with the angle where we had it split apart is definition of angle bisector. AC is congruent to AC is reflexive. And let's see if we can piece this together. I have BC and DA, that's helpful. AC bisects BCD. But is that enough to piece this together? I know I'm taking a little bit looking at this. I am double checking my own work because I have some concerns with this proof. My concern lies with this side right here. Because really, we need that in order to prove. I would have edited this to say that this would be CD. This would be CD. Because if that is in fact our congruent side, we have side, angle, side. Now, I know that was probably a bit painful waiting for me to figure that out. I'm going to crack my typical math humor and say don't get some sass with me over it. Just bear with me. And let's continue on. I'm going to scroll down and see what we have. Uh-oh. Now we've got one without pieces given to us. We're going to have to write this out ourselves. So let's start with statement and our reason. Let's see what we get. We can start with our given angle A, D, B, and angle C, D, B are right angles. Sorry, I should have left myself some space. That's given. It's also marked in the picture. And angle A is congruent with angle C, given. So they were nice to us and marked our picture. Now, one thing is, and this is a statement I may have missed earlier, is this part about the 90-degree angles. Double check with your geometry teacher, but one of the things I want to point out is if those are both right angles, then angle ADB should be congruent with angle CDB just by definition of congruence. What that step looks like, this is a condensed version, is since angle ADB and angle CDB are right angles, I could say that angle ADB equals 90 degrees, angle CDB equals 90 degrees. My next statement could have said that angle ADB, or the measure of, is equal to the measure of angle CDB, which is called substitution, giving me a last step, which we have here in the problem, that angle ADB is congruent to angle CDB, because the definition of congruence says when the measure of two angles are equal to each other, then those angles are congruent. Again, double check with your teacher to see if that is how they want it done. Either it can be done in one step or multiple steps. It's about 3 over here. But let's finish from that digression. Next, notice they share a side. BD, or I'm sorry, I should go in the order of DB, since that's the order it's written in here, is congruent to DB by the reflexive. Again, one of our most helpful tools. So I have an angle, and a side. Therefore, triangle ADB is congruent to triangle CDB by angle, side. All right, there's not many more. You may not have made it this far, but let's go ahead and knock these out just to cover our grounds. I'm going to make my chart over here. Hopefully I have enough space to write. We have C is midpoint of BD and AE. And that is very poor writing. Writing on a smartboard, real tough. That's given. That tells me some things. That AC and EC are congruent. So AC is congruent to EC. That also says BC and DC are congruent. You could write this all in one step or separately, it's up to you. I'm just going to write the reason once because they're the exact same reason. Definition of midpoint. Now, I have two sets of congruent sides. Take a look at this picture. Do you notice any special angles we can use? My hope is you recognize the vertical angles here. I hope you recognize that angle BCA is congruent to angle DCE by the vertical angle theorem. If not, we need to start focusing in on that and recognizing that in pictures. From this, we're actually done. We have angle in between two sides. So side, angle, side tells me that triangle ABC is congruent to triangle EDC. All right, just one more. I know this video is getting kind of long, but I wanted to make sure I covered as much as possible. All right, let's make our chart and see what we have. We got two given statements. A B is congruent to CB, and BD is median of AC. Now that's something we haven't seen yet. And I want to point out some pieces about a median. A median cuts this apart. We also have reflexive we can use, and they gave us that AB and CB are congruent. So the parts I need are that AD is congruent to CD, and I need you to research what this reason is. I'm right now just going to write median, but you need to figure out what that statement is. It could be definition of a median. It could be a theorem. Go back and check your vocab. But in that picture, I see, oh, I forgot to say that BD is congruent to BD. Again, I want you to notice that that's the order in which it's written in the name. by reflexive, and now I have three sets of congruent sides. So triangle ABD is congruent to triangle CBD by side, side, side. I hope this helps. I know it's a half-hour video, which meant it's like sitting through another lesson, but the only way to really get an understanding what's happening is not so much to keep drilling it, but to see a variety of different problems so that you get an understanding of the relationships.